Hello my friends. So we did mention that we are going to carry on and look at these questions, that is question A, question B and question 3. But before we look at those questions, I wanted us to look further and see the current division and the voltage division rule. So we begin with the current divider rule, what we call the current divider rule. This is going to simplify a lot of understanding of these questions when we look at how current splits. So in this process, we are saying there's a current which is coming from the source, and as it reaches this node, it splits into I1 and into I2. And how do we obtain these values of the currents? Using what we call the current divider rule. So in this scenario, the total current being I is going to be given by I1 plus I2 according to KCL, Kirchhoff's current law. So the sum of currents entering this node is equal to the sum of currents leaving this same node. So from Ohm's law, we know that the current I1, which is this I1, is going to be equal to the voltage over resistor 1. And remember that the voltage across the voltage across circuits that are in parallel is the same. So the voltage V here is the voltage across resistor 1 and the voltage across resistor 2. So therefore, what follows then is that when we begin to solve, I1 is equal to V over R1 and I2 is equal to V over R2. And when we apply KCL and replace I1 by its Ohm's law value and I2 by its Ohm's law value, we obtain voltage to be, we factor out voltage and we remain with 1 over R1 plus 1 over R2. And if we divide I1 by the total current, then we're able to determine the value of I1 by what we call the voltage division principle. So we divide I1 by the total current, and we determine that we have the numerator to be R2, R1 plus R2, which is basically a ratio. And this is going to be equal to the total current multiplied by resistor 2 over the sum of the two resistances. In a similar way, we are able to achieve the calculation for I2 using the same principle, but in this case we have I1, R1 over the sum of the resistances. So this is the ratio. We're basically obtaining a ratio between the two resistances. So in case where we're looking for I1, we are looking at the ratio of R2 to the total resistance. And if we are looking at I2, we are looking at the ratio of R1 to the total resistance. And that determines and gives us the current divider, what we call the current divider rule or the current division rule. And we shall see that as we apply it in some of the examples. Now, the voltage divider rule on the other side looks at the resistances being connected in series. And this is applied again by applying Kirchhoff's voltage law around this closed loop. So we are saying voltage, the sum of voltage sources should be equal to the sum of voltage drops. In this case, we have V being equal to V1 plus V2 plus V3. But then we know that our V1 is I, the current in series circuits or resistances is the same. Therefore, what we have is V1 is equal to I multiplied by R1, V2 is equal to I multiplied by R2, as again V3 is equal to I multiplied by R3. Then when we add those together, we can factor out the common current, which is I, and then we remain with R1 plus R2 plus R3, and this is now the total voltage or the applied voltage in the circuit. And then from Ohm's law, if we are to determine the voltage across resistor 1, which is V1, then we determine it by the current multiplying by resistor 1. So if we come to, again, dividing V1 by the total voltage, what we come up with is that we have V1, which is I R1, and then we've got at the base here we've got the total voltage or the supply voltage, which is V equal to I multiplied by the sum of the resistance, the resistances. Sorry for that. So when we come at this stage, we can then cancel out the currents. So the currents all cancel out. So this current cancels out, and what we remain with is simply resistor 1 over the total resistance. And for V1, we get to find that V1 is equal to the total or the supply voltage. The numerator will be resistor 1 over the sum of resistances. And in a similar way, when we come to get to obtain V2, we find that it is the same, where we have the supply voltage, but then we have R2 there over the total resistance. So the voltage division rule is quite straightforward. Whatever resistor that you are looking for, if you're finding the voltage across that resistor, that becomes the numerator, and then you add up all the resistances that are in series. And that is the current division and voltage division rule. Now let's look at those examples that we discussed and we said we can analyze. The first example we had was the first example we said we had a circuit that appears as follows. We had the 20 volts source, and then we had a connection. We had, let me draw the boxes for the resistors. So resistor 1, then we had resistor 2, then we had resistor 3 here, and resistor 4. So if you remember, all these resistances are connected like so. And the values for these resistances were, this was 20, this resistor was 30, and then this resistor was 40. So we are saying this is resistor 1, resistor 2, resistor 3, and resistor 4. And what we have here, we've been given to find the current that is flowing, which is I1, and then there's a current flowing there as I2, and then there's another current flowing there as I3, and then another current flowing through there as I4. Now, if you remember, the question says let's find the currents as well as the voltages across each resistor. So what we have to first of all find is we have to find the total resistance. So when you look at this circuit, what you see is that these resistances are all in parallel. So we can have a total resistance here, which we are going to call R equivalent 1. And that R equivalent 1 is found by determining the total resistance of these parallel circuits. So to get this, we have to find 1 over R equivalent 1 should be equal to 1 over 20 plus 1 over 30 plus 1 over 40. And that is what we determine to get the total resistance. And then when we get the total resistance from there, Req1 gives us, so we get about 120 over 13, which leads to 9.23 ohms. So that is the total resistance. Therefore, our circuit is simplified and it appears as follows. So we've got the source plus minus, then we've got resistor 1, and then we obtain our next resistor, which is the Req resistor value. So we found Req1 here, and here we still remain with R1. Now, if you remember, the values here are, we've got 20 volts there, and then we've got R1 was 10 ohms, which is 10 ohms. So this is also 10 ohms, and we found this to be 9.23 ohms. Therefore, we are able to determine the total resistance of this circuit. Remember that these two resistances are now in series. So this is series. And because these two resistances are series, they're basically added together. So our total circuit then becomes simply a source and one resistor, which we determine to be the sum of these two. So when we add those two, we get a value of so the total resistance, which in series is RT, is simply 10 plus our 9.23, which gives us 19.23 ohms. And here we have our 20 volts supply. So a current is going to flow in this circuit in this direction. So you've got a current, total current, which we can call I1. So we can label that as I1. And to find our total current, we can say now our total current, or IT, I total, is equal to the voltage, total voltage, over the total resistance. And this is coming from, the voltage is 20 divided by 19.23. This gives us a value of 1.04 amps. So having found our value there, then we are able to say, okay, since we have found the total current in the circuit, that is the same current that flows through resistor 1, and that is the same current that flows through the Req1, because these two resistances are in series. And if you remember, series resistances have the same current flowing through them. So therefore, we are able to quickly determine the voltage across these resistors. Okay, so we can say the voltage across this resistor Req1 can be determined easily. So we are saying the voltage across Req1 is equal to the current multiplied by the resistance. Our current is 1.04 multiplied by the resistance, which is 9.23. And using that equation, we're able to determine the voltage to be 9.6 volts. This 9.6 volts that we found is the voltage now across here. So this is 9.6 volts across here. And since we know that the voltages in parallel circuits is the same, this implies that when we look at this circuit here, the voltage across these two terminals or these nodes, which are the same nodes, this and that node, is 9.6 volts, meaning across the 20 ohm resistor we have got 9.6, across the 30 we've got 9.6, and across the 40 we've got 9.6. So we are able to now determine the currents I2, I3, I4 by basically using Ohm's law. So we are saying the current now I2, which, if you remember, we found the voltage to be 9.6 across, and then we've got R2 is 20 ohms. And therefore, if we calculate that, we are going to get the 9.6 divided by 20, which gives us 0.48 amps. And in the same pattern, we're able to determine the current across resistor 3, which is 9.6 volts divided by 30 ohms, and that gives us 0.32 amps. Again, if we come to the current through resistor 4 is going to be 9.6 volts over we had 40 there, and that gives us 0.24 amps. Now, having found these values, we're now saying, is this true? Can we verify that these values are correct? And we are saying, if we apply KCL to if we apply KCL to this node, okay, we come to this node. So we've got I1 entering, and we've got I2, I3, I4 leaving, and therefore we are supposed to get I1 must be equal to I2 plus I3 plus I4, and this is what we want to show. So if we want to show that, then we are saying from KCL we can say I1 must be equal to I2 plus I3 plus I4, and when we add here, we've got 1.04 for I1 amps must be equal to 0.48 plus 0.32 plus 0.24. When we add, this is 1.04 amps is equal to 1.04 amps. So therefore, we are saying KCL is verified. And then using those variables, we're able to determine other values as well. Now we can determine the voltage across the resistor resistor 1. So resistor 1 has got a 10 amps flowing, has got 1.04 current flowing. So we are saying, what is the voltage across resistor 1? VR1 is therefore now equal to, we've got current times resistance. So if 1.04 times the resistance, which is 10 ohms, and this gives us 10.4 volts. Okay, 10.4 volts. So we've found all the values for this circuit, and we are done with this circuit.